Linaro CEO.
Thanks very much, Joe. Welcome, everyone, to the 22nd Linaro Connect. Thank you all for coming and spending the week with us, and we hope that this is going to be the best Connect yet. So, first, what I'd like to do is offer a special welcome to some new Linaro members. Kylin, or Chilin in China, was established in 2007 and offers a leading Chinese Linux distribution based on Ubuntu. They also offer security and cloud platform software products, and we're really pleased that they've joined LEG with strong interest in the ERP project and in aligning with Linaro. Next, we're delighted that NXP, who are already a member of LNG and Light, have also joined the Digital Home segment group, and they have particular interest in OPTE and secure media technology. And finally, I'm very pleased to announce that Xilinx has joined Light. As a leading company in FPGA technologies, we're really pleased to welcome Xilinx to Linaro, and we look forward to having them join our collaborative engineering efforts. So we have over 300 engineers comprising employees, member assignees, and member engineers now working in Linaro. Since the last Connect, this team has worked together in over 50 open source projects, continuing to deliver software upstream across market segments to benefit members and the ARM ecosystem. And for details, you can refer to monthly engineering reports that we produce, members can, but I do want to highlight a few recent achievements. Firstly, OPTE. The Security Working Group successfully upstreamed the generic TEE driver and support for OPTE into the Linux kernel version 4.12 since the last Connect. And we're seeing increasing adoption of OPTE across the ARM ecosystem. It's taken a long time, but it's a great job having a fully open source trusted execution environment available. Secondly, LEG released the 1708 ERP release, and this includes UEFI, ACPI, and PCIe support, and the 4.12 kernel running across all of our members' hardware. In addition, this release includes new packages and updates for BigTop, Ceph, DPDK, Docker, OpenStack Newton, ELK, OpenJDK, and a whole bunch more stuff. And all of this is tested and validated on member ARM platforms. What's unique about this is that the source code is all available to the entire ecosystem, and the ERP is used to run the developer cloud, offering bare metal and virtualized access to developers worldwide. In addition, LEG's new HPC Special Interest Group made significant contributions to ARM support in the recent release of OpenHPC 1.3.2 with work from Renato and engineers from ARM and Fujitsu. So that was a really good job getting started so quickly with the HPC group. Finally, Light has been ramping up through the year and recently made some substantial contributions to the latest Zephyr 1.9 release, including the LWM2M stack that was delivered by the Linaro Technologies team as part of their ongoing end-to-end connected devices work. So please go to linaro.org/downloads and see the many other projects that our teams have been working on. But it's not just Linux. Linaro engineers are working across the ecosystem and are involved in many, many other projects. If you're interested for more information and detailed metrics on Linaro contributions across the open source ecosystem, go and take a look at patches.linaro.org, and it breaks down all of the contributions that Linaro makes across the ecosystem. Okay, so this is a quote from NHL hockey player Wayne Gretzky that's been used before in some technology presentations. But I think it's really important for Linaro today. All of us need to be working together to lead open source software projects, not just to follow our competitors and get ARM parallel to them. We need to be leading. And so working upstream, we know, requires a lot of time and effort. And our steering committees need to be working not only on today's problems, but we also need to be looking ahead so that we can prioritize our resources most effectively. We need to go to where the puck's going to be. Most importantly, we need to prevent fragmentation in technologies that are really non-differentiating before it happens. It's so much better to do that than trying to clear up afterwards. So where is open source going? I think we're entering an era where an unimaginable number of connected devices, including lights themselves, will have as much of an effect on society as the invention of the incandescent light bulb itself. And I firmly believe that open source software will be at the center of this transformation. Open source is a key technology for all of the topics that are listed here. Let's just pick one and talk about security for a moment. Security encompasses hardware, software, and absolutely definitely human interaction. We live in a world where core technologies include connecting devices, including connected devices. They need to use global and not just national standards. Countries won't trust black box security platforms from one another. And from a software perspective, open source solves many problems. It enables global standards and specifications to be created, building on the collaborative work of engineers across the globe. It enables developers and hackers alike to see the software and probe its weaknesses, resulting in a more trusted standard way of securing programs and data. And then each country or company can build their own security value add on top of a secure platform. But security will never be absolute. And for all connected devices, it is critical, as we talked about in Budapest, that companies support software over the whole lifetime of a connected product, enabling it to be updated at any time. If you don't do this, the alternative is risk of significant loss of brand value while you scramble to fix your products. Okay, so what about artificial intelligence? This is the latest overused buzzword and the current hot technology topic. Nobody can present a business plan to a venture capitalist today without talking about artificial intelligence. Where is this puck going? Well, in Linaro, we're fortunate enough to have two doctors working in this area. Dr. Kanta Vakaria is chairing the HPC Special Interest Group in LEG, and Dr. Yang Zhang, who heads up the 96 Boards program, has extensive experience and interest in machine intelligence. Kanta is going to be addressing and discussing AI in a keynote tomorrow, so I don't want to steal her thunder. But if you have interest in this area, please make sure you talk with Kanta and Yang this week. And if you have an interest in the area because of work you're doing in your company, please also talk to us about what you're doing. So in Linaro, Yang has been encouraging some investigative activities into machine learning and computer vision on existing ARM processors using the 96 Boards program. And over recent months, we've been working on compiling machine libraries shown on this slide for use on ARM. One of the things that's clear is that there's an arms race, no pun intended, developing to use specialist hardware including GPUs, FPGA, and dedicated accelerators to optimize machine learning performance. And I think this is a really good example of looking at where the industry is going and needing to stop fragmentation before it becomes a problem. In the ARM ecosystem, we need to lead, not follow. If anybody's had a play with Google's TensorFlow, you'll know that you have two options if you want to compile it for ARM. You basically use the CPU cores, or you use CUDA, which is the proprietary NVIDIA technology. Anybody who wants to use TensorFlow on their own GPU or their own custom hardware has a lot of work to do. And so I'd like to suggest that the HPC SIG, the Linaro TSC, consider what APIs could be used to abstract underlying hardware optimizers from the mainstream machine learning libraries, a bit like ODP for network data plane acceleration hardware. We're going to show you a very brief demo. You may have noticed that there's a noise going on in the background because it keeps recognizing my face. One of the things that we did over the summer was we took a look at exactly the scale of the problem that we faced. And we're going to show you what we've done to date on mobile class ARM hardware. We're using the original High-Key for this demonstration, which is, has 8 A53 cores, and we're running Debian Linux. So what I'm going to do here is first see if it, well, it obviously does recognize me because it keeps saying my name. So we've got that one down. To keep this relatively quick, this demonstration uses OpenFace from CMU, Carnegie Mellon University, which is a Python and torch-based face recognition system using deep neural networks and the dlib machine learning library. With no access to the GPU, we're only using the A53 cores, and we've made no attempt to optimize performance. The model for this has been trained with some of the UK team's faces, including myself, Rob Booth, and David Rustling. So let's see it in action. And we've got a camera here, a live feed from the HDMI output from High-Key up there, but you will see a lag. In fact, you won't see anything at all. Yes, you can see it. I don't know if the window's there. But let's first see if it recognizes me. It did. I've loaded a couple of pictures of the UK team to see whether they're recognized correctly. So first, Rob Booth, our COO. It does seem to have stopped running, but it did keep saying my name. So maybe we'll pick up that demo later. But what it did is it basically takes each face and it's providing recognition with a statistical probability that that is the right face. But given that it's been going for a while, I think the High-Key ran out of oomph, so we'll save that demo for another day. So what I'm going to do is move on, and if I can go back to the slides, and talk a little bit about the implications of AI. It's getting a lot of attention these days, as you can see from these two quotes. Aspects of AI can undoubtedly save lives. When most cars are self-driving in the future, we should see far fewer deaths on the roads. And I know that huge strides are going to be made in healthcare from drawing inferences from larger and larger data sets. But this technology also presents new ethical and privacy issues. And as we ask computers to do more and more, are we creating an existential threat, as some think, or is it the path towards global prosperity and peace? We just don't know at this stage. And I think certainly open source is proving to be a powerful way of developing AI tools, and it's dramatically increasing the number of researchers working in this space. But the risk of misuse of these tools is growing, and it's being highlighted by a number of researchers in the area, a number of high-profile technologists, and is being worked on by groups such as the OpenAI group. If you're not familiar with their work, they're researching how to develop AI in a safe way, and I encourage you to look at their website. Despite recent events, creating a nuclear bomb is very hard, and it's very expensive. And it's also pretty easy, relatively, to see from what's going on in terms of testing where those tests are happening. On the other hand, compiling and modifying code is incredibly easy. And we have low-cost access to pretty much unlimited hardware resources in the cloud available to anybody who wants them. There is no barrier to working on this technology. So even though we maybe don't know where the puck is going, as an industry and a society, we need to think about the implications of this new technology as we create it. And I fervently hope that we will do that in the open rather than behind closed doors. Okay, let's turn to another place where we need to be thinking ahead and where open source is having a significant impact. Sadly, this is not my car. A number of Linaro members have interests and products in the automotive space. But there are two companies who are dominating the high end of self-driving hardware today. Intel with the Intel Go platform and NVIDIA with the PX platform. Both are expensive, neither is open. So could Linaro members and the wider ecosystem work together for mutual benefit on a more open platform that could get cross-industry support and accelerate the business opportunity? What might such a platform look like? So, from a hardware point of view, we could envisage a camera complex multiplexed from HD USB 2 cameras into a USB 3 pipe, 5 gigabits, bringing those multiplex signals in, and additional interfaces for LiDAR and ultrasonic cameras. And then you need sufficient processing power to perform the vision processing, needs quite a lot as we've just seen, object recognition, and ADAS facilities. So maybe what we should do is create a 96 boards automotive reference and enable SoC vendors to provide different solutions in a common footprint that could easily actually be installed into simulators and cars. On the software side, Linux is today mostly used for non-safety critical IVI functions. But as the trend moves towards creating dedicated high-performance SoCs for automotive, we need to do better at thinking about what the software platform and architecture looks like. And at the lowest level, a certifiable layer of software is needed that meets the needs of safety-critical systems and legislation. The SEL4 team have been working on a microkernel that uses formal verification for proof of correctness and security enforcement. And they're here this week and giving sessions. I thoroughly, if you're interested in this area, recommend you attend those sessions. On top of that, we might have a minimal Linux implementation supporting containers for running the different high-level components. For example, the IVI system, vision processing, machine learning, artificial intelligence, and so on. And security and over-the-air updates are absolutely core platform requirements for this space. If we could create something like this, then such a platform would enable the open source community to get more involved in the future of this development. As a simple proof of concept, we're using 96 boards to interface a mezzanine board with PX4, GPS, and CAN bus to a Dragon board running Linux and providing camera, LiDAR, display, and storage. What we plan to do is install that into a product from a UK startup called Street Drone, who are creating a low-cost self-driving vehicle for developers based on the Renault Twizy electric car. So maybe at the next Connect, we'll actually be able to demonstrate a car on the stage running on open source software. For those here with an interest in the automotive space, we're having a set of sessions and meetings tomorrow, and the goal here is to gauge the level of interest in our members and wider in the community in starting a more formal collaborative effort. Please contact David or Yang for more information. Speaking of 96 boards, there's been a lot of momentum building over the last months, and particularly since the last Connect. There are many new companies joining the 96 boards ecosystem as steering committee members and manufacturing partners. There are many new boards in design. Please talk to Yang if you have interest in 96 boards, but here are a few of the recently announced products. The HiKey 960 brings the latest ARM technology, including A73 and A53 clusters, G71 GPU, RAM, UFS flash, USB 3, and mini PCIe. Android support is available for this board in AOSP, and we're also working on Linux, although we need more effort to get good upstream support for this device. If low cost is important, the Orange Pi i96 IoT Edition board runs Ubuntu, includes a camera interface, and costs only $9. You can go and buy it today. And also for IoT applications, there's a new board from Hope Run that uses TI's Wi-Fi solution and runs Zephyr. There are two interesting boards, mezzanine boards that have now come out. One is the Neon Key, which includes an ST Cortex M4, has multiple sensors on it, and also an LED ring, and it's also supported in AOSP. And we've also just started delivery of the Secure 96 board, which there's a session that Joachim, the Security Working Group, is giving this week, and that features two low-cost crypto devices, as well as a TPM chip, and this will enable us to show how to use security hardware assist, if you have it, as you develop open source software. We want to basically create best-of-class security solutions in open source using OPTE and demonstrating how to do things in both software and in hardware in a best-of-class way. Also related to 96 boards, at the last Connect, we talked about how to build software natively on ARM for ARM. Since then, we've made some good progress. First, ARM now have three, what they call FVP, fixed virtual platforms for 64-bit development. The foundation platform is a single ARMv8A cluster with a simple peripheral set for Linux application developers. Then they have the base platform, which is a dual cluster with an extended peripheral set, including GIC v3, SMMU v3, and CCI. And that supports the latest public ARMv8A specifications. Finally, they have a system guidance platform, which is for mobile and network applications. All of these are now free of charge and license-free, and you can get them from developer.arm.com. Of course, we also have the Linaro Developer Cloud, which is providing developers access to our members' 64-bit ARM servers located in China, the United States, and the UK. And Packet.net are also making additional bare metal ARM servers available to the ecosystem. So we're dealing with developers here who are able to actually bring up their software and use either virtualized or bare metal systems in the cloud using ARM servers to do either testing, CI, bring up, port their software, make sure it works on ARM. I'm also delighted to tell you that tomorrow, the chief executive of SocioNext, Nishiguchi-san, will be making announcements about a partnership between Linaro, Gigabyte, and SocioNext to bring an ARM developer box and 96 boards Micro ATX product to ARM developers before the end of this year. And some of the Linaro team, including Leif and Ard, have been working very hard with SocioNext on the open source firmware for this project. Look forward to a demonstration of this work tomorrow. What's really interesting about that product to me is not that its single thread performance is going to be particularly high because it's based on A53s, but the fact that there's 24 of them on a single core and it's only using 5 watts of power is, I think, really interesting. And I'm really looking forward to seeing what the developer community do with something that's different from a standard 2-core chip. Okay. This year, the small Linaro Technologies group has been building on the proof of concept that we first showed a year ago in Las Vegas. The goal has been to demonstrate secure, over-the-air updatable open source software end-to-end from sensor to cloud running on ARM technology. And in order to do that, we're building on work that we've been doing in Linaro and that's available in upstream projects from Light, Leg, and the other Linaro teams. And all of this work has been made available as we've been going along to members in the community. Today, what I want to do is update you on some progress. As part of this work, we've coined the term micro-platform to describe the software that we're running on both Cortex-M and Cortex-A devices. So what is a micro-platform? Well, we're defining it as an open source platform, software that is minimal, secure, over-the-air updatable, and provides standard programming interfaces for developing services and applications. It includes open source firmware, example code from the first instruction executed on an MCU or SoC once control is passed to the software developer. And we've been working on 2 micro-platforms, one using Zephyr for Cortex-R and M, and one using Open Embedded for Cortex-A. So first, let's take a look at the Zephyr micro-platform. This provides all of the non-differentiated pieces needed for a connected device based on a microcontroller. So security, OTA updates, and industry-standard wireless and IoT protocols are built in from the outset, all open source. And the micro-platform is based on the upstream MCU, Boot, and Zephyr projects. And at present, we're building 2 configurations, one for UDP CoAP DTLS LWM2M, and the other for bigger devices with full TCP IP, MQTT, and HTTPS support. The goal of these micro-platforms is to make them easily portable across different SoCs while maintaining the non-differentiated core software so that developers don't need to reinvent the wheel for each new connected or embedded project. And as we started to use Cortex-A devices on 96 boards for this end-to-end platform, and we started to use other community platforms, given the work that's being done in Light and the architectural direction for gateways in the EdgeX project, it was clear that a Linux micro-platform should be the minimum configuration required to be secure, updatable, and to run containers. We see containers as being key not only for data center and enterprise deployment and DevOps, but also for advanced connected devices. And even in our simple gateway use case for the micro-platform, what we do is we use small containers to handle services such as Bluetooth proxy, IPv6 to IPv4 handling, and the MQTT and LWM2M interfaces for the minimal bridge functions that we need to actually go from devices to the cloud. This is a work in progress. The demonstrations that we're going to show you today use a headless open embedded build that runs on a number of boards, including High-Key, Dragon Board, and Raspberry Pi, that can easily be extended to run on other boards with good open embedded upstream support. So our vision here is for a base open source platform that has widespread applicability across different market segments for connected devices, from high-end sensors to smart connected devices, and from gateways to network nodes to the automotive platform that I discussed earlier today. Using a common open source platform across these multiple segments will reduce non-differentiating engineering effort, speed time to market, and increase product quality and security through reuse of an open source shared platform. And application-specific services and software stacks will be delivered on top of the Linux micro platform, over the air, in containers, as open source or commercial software. We think this has application and use across the ecosystem. And so Linaro, and indeed the work and the team that's doing this, are not expecting to build a big distribution, have a huge services organization globally. We actually think this core technology, the firmware, the kernel, the best practices in terms of how we're implementing this technology in the open source community will benefit the distributions, OEMs, ODMs, cloud providers by giving easier access to devices, and will also make it easier for developers to create products that are safe and secure. And the more of our members who participate in this, the better it will be for the entire ecosystem. So what we'd now like to do is see if we can demonstrate the latest builds. Now, I would preface this by saying we're showing some pretty new technology here. We have been using it for demonstration, but we have not before. We have some Bluetooth technology devices here, but we haven't before put it into a room with 400 people. We thought of inviting you all to come a couple of days early so we could do some tests, but then we thought we probably didn't want to ruin your weekend. So this is the first time we've ever done this, any of these demos, with this amount of Bluetooth noise from all of your phones. First, what we're going to do is demonstrate an end-to-end ARM platform gathering temperature data from a number of carbon and nitrogen 96 boards IoT edition. I'm going to ask Tyler to come up and help drive this demonstration while I tell you what's going on. I certainly can. So what we're doing here first is we're using Zephyr micro platform, using BLE, MQTT, TCP/IP, and HTTPS, and we are running that on a number of carbons and nitrogens. The red ones are the carbons, the blue ones are the nitrogens. This is a power supply, a battery. And then that is connected to a Raspberry Pi. This is simply being used as a wireless gateway, talking Bluetooth to the devices and talking Wi-Fi to the cloud. Now, the cloud system we're using is the Linaro Developer Cloud. So we're running there Hawkbit, which is an open source device management platform, and we're doing that in a container on OpenStack on the developer cloud, which is running the enterprise reference platform. So everything from the sensor to the server is open source running on ARM technology. So Tyler, would you like to first show us the Hawkbit deployment management dashboard, which we've got up here? So what we have here is you can see the different carbon and nitrogen boards in the targets. You can also deploy, if you wish to, updated versions of the software securely over the air to devices. But what we're going to do here is we're just going to show you the temperature sensor data coming from the nitrogen and carbon devices. So what you'll see here is that we have a number of these devices. One of them seems to be offline at the moment, but we have the nitrogens and carbons, and you see the temperature in the gauge, and you also see the tracking there. So what I'm going to do is see if we can heat these up a bit. Useful that it's portable. And I have my hairdryer, so we'll, I don't have much hair, so it's no good for this, so I'm going to use it for this. So we'll heat these up a bit, and hopefully what you'll see, we look at the, can we go up to the top, Tyler? There we go. So you see the temperatures are starting to climb on the various devices. I can see actually a couple of them are disconnected in the, but there they go. So this is actually showing completely end-to-end software running on ARM. Okay, so we've kind of shown similar things before. What we've just done is shown end-to-end demonstration using ARM microcontrollers through the ARM gateway to ARM servers, running open source device management and dashboard software. So next what we want to do is show the new LWM2M functionality in the latest Zephyr release 1.9, demonstrating a microplatform UDP CoAP and LWM2M build. And at the same time, we thought we should change things up a bit, and this time we should use open source Lashan device management software, which is LWM2M compatible. And given that we were recently at a member meeting in Tokyo and talking to SoftBank, we thought we'd do this on the SoftBank cloud in Tokyo. I will admit this uses Alibaba's infrastructure, which of course is x86, but I think we're going to have to coexist for a while yet. So we're going to demonstrate this using completely different hardware. Now, in order to do this, we're actually going to use the same gateway. What we're going to do is we're going to reconfigure the Raspberry Pi gateway to, instead of talking to our cloud, the developer cloud, we're going to reconfigure it over the air to talk to the Alibaba cloud, to talk to the SoftBank cloud, which is the Alibaba cloud software, running in Tokyo. And this should only require Tyler to change a single variable to point to a new server, and he will then use Ansible to reconfigure the gateway over the air. So if we can bring up, and what Tyler is doing here is he's changing where the cloud is pointing to from the Linaro developer cloud to the Alibaba cloud. And what he's now going to do is use Ansible to basically redeploy a set of containers. It's there cleaning up the old ones, and it's going to take a minute or two while it deploys the new ones. So what we're going to do this time is we're going to show you, can you pass me one of the lights, Tyler? This one. We're going to show you some lights that we've created as open source demonstrations for this particular event by adding a low-cost maker-style BLE module from Red Bear into an off-the-shelf battery-operated light bulb, which we picked up on Amazon and you can get from other suppliers. So just think about what we're doing for a moment. If you today go and buy a smart light bulb for your home, you receive bulbs, you get a gateway device to connect to your Wi-Fi network, and you get an app for your phone. It's all closed. You can't see any of the software, but it all works. You can go and get a Philips Hue device. That's great. Problem is, when you buy another manufacturer's light bulbs, you get another gateway device to connect to your home network, and you get another application. Why? Just using the technology we're demonstrating here, we can imagine a world where you basically get additional devices and you do a simple over-the-air update of the gateway software, and that can include either open or proprietary manufacturer software. We're actually showing it to you completely with open source. And it's now done, and we're ready to go. So what Tyler can now show us is that the lights have been registered with a Lashan dashboard using the updated gateway software. But first he's going to log in, so you just have to click on the, oh, there you are. Yeah, show the IoT platform. Oh, so okay, so here we are. So what we're doing here is we're showing the Lashan dashboard, which is using the updated gateway software, and that's seeing a number of devices, including the 3 devices, the 3 lights that we have here, but also some additional devices we're going to use a little later. So what he's now going to do is show you how the Lashan interface works and how we can find out information from the lights and how we can control them. Tyler.
Sure. So what we're going to do is look at this first light here, and we're going to do a read on it. And it gives us some basic information about what the platform is, the SoC that it's running, and the software load. What we can also do is trigger the light to turn on by just writing a value here and hitting update, and that light should turn on. Yeah.
Turn mine on?
We can turn yours on too. So we'll do the same thing for George's light.
Yay.
And we'll do this one here as well.
So this is actually pretty amazing. We're doing this from Japan. Can we dim them, maybe?
How about I dim yours?
Yeah, dim mine.
Oh, how about I turn it up for you?
Okay, make it bright. Yeah, these guys can't see it. There we go. All right. Okay. So, of course, we could do this locally from the gateway, but that's not nearly as cool as doing it from Japan. Okay. So we want these micro platforms to be cloud agnostic. We'll work with cloud commercial vendors to ensure interoperability. But again, we were in Japan. We were meeting with SoftBank for the members meeting. And we got to talking to the SoftBank IoT platform team, who are here this week. Welcome you to go and talk to them. And this is different from the SoftBank Cloud that we've just used. The SoftBank Cloud is a commercial cloud provider, just like AWS that SoftBank running on Alibaba infrastructure. The SoftBank IoT team are providing services for deployment and management of IoT devices. And the SoftBank IoT platform uses the 1M2M standard to provide services to manage these devices. That standard is particularly used in Asia by service providers. Now, this time, the Zephyr micro-platform devices that we're using are going to use native HTTP through the gateway to send 1M2M messages to the SoftBank platform. And then we have a dashboard that pulls the data out of the SoftBank platform to show you what we're doing. In future, we can also enable LWM2M co-app devices by simply providing a gateway container to produce the LWM2M to 1M2M proxy. So first, Tyler's going to show you the SoftBank IoT platform dashboard receiving data, again, from some nitrogen and carbon sensors.
Thanks, George. So here's our nitrogens that we have here. And this is the SoftBank IoT platform dashboard, and we can look at some of the assets that we have connected. So this is one of the boards here, and we can do a quick read and see some of the JSON data, the raw JSON data that it's sending. So you can see that we're sending MCU temperature back to the IoT cloud.
Okay, great. Next, can you show us the dashboard we've created to show this? Can you give me the devices? I'm going to make that hairdryer work again and make sure that we're actually doing this live. Okay, here we go. So this time, we're polling less often. These are LWM2M devices, and they take a little longer to therefore show what we're up to. But what you should see soon is, there it goes, the temperature's starting to rise. And again, these devices are transmitting data to the other side of the world in real time, and we're seeing that data being retrieved in real time. Okay, thanks very much indeed. Okay, so we have one last thing that we want to show you today. We want to show you the latest BLE software that's also supported in Zephyr 1.9, which is the recently announced BLE mesh technology, which enables BLE devices to be used in a mesh network. Now, we have no idea whether this demonstration is going to work. But what we've done is we've placed a number of lights around the room, And we're going to see if we can make them connect in a Bluetooth mesh when all of you, I'm sure, have phones in your pockets as well. So these have special software that we've put in to demonstrate what we're doing. And if they're directly connected, we're actually going to control them. Ricardo's going to do the controlling. Ricardo's sitting here in the front. And he has an Android tablet, put up your tablet, which he's going to use to control the mesh, an interface to the network. And the software on the lights is going to put the light solidly on if it's directly connected to the tablet. But if it's actually connected to another lamp, creating a mesh, then you'll see rapid flashing. We're trying not to do this too fast. If anybody does have problems with flashing lights, you might want to look down during this demo. But there will be flashing lights relatively quickly that will show one hop. If there's actually two hops, i.e. there's a lamp talking to another lamp talking to the tablet, then the lamps will flash more slowly. So what we should see is some of the lamps flashing fast because they're connected through one hop, and if we've got enough space, some of them running slowly. Now, if the effect of all of you is to completely blanket the Bluetooth network, then we may have to move some lamps around to show you what's going on, but we'll see what happens. So, Ricardo, I'm going to hand this over to you.
All right. So, I'm going to use this tablet to control the devices in the BLE mesh network. And since the software stack of the tablet doesn't yet talk BLE mesh natively, I'm going to use one of the lamps as a proxy so I can talk and control all of the BLE mesh devices. So as a test, let's just enable the first lamp, which is actually the proxy, as George just explained, is fully on, fully bright, right? So now let's see if the other device is actually going to work. All right. You see that they behave kind of the same way. The blinking pattern is the same, which means the distance is also kind of the same to the proxy. So let me try something more fun now, which is turning on all of those devices, including the ones right in the back.
So we have all the lights going. In fact, the mesh is going so well that everything is just one hop away.
It didn't actually use the relay. It's amazing.
Which is pretty interesting. So this morning when we did this, we had some of the lights going more slowly. And so, there we go. So at the back, you will see those lights are flashing more slowly, which means that they're actually 2 hops away from the tablet. And actually, interestingly, the more devices you get, of course, the more efficient the mesh is. So this is a demonstration for you of Bluetooth mesh, open source software, and I think it's one of the first times this has been shown, certainly on this ARM technology. So well done, team. Thanks very much, Tyler. Okay, so all of the code for the demonstrations you've seen enabling anybody to replicate what we've done, all of this is pretty much off-the-shelf hardware, low cost, is available on GitHub today with full documentation on how to build all of the software from scratch. So if you're interested in replicating what we've done and building on it, then it's all there. It's all open. So what we've just seen is end-to-end open source IoT to ARM Cloud, the Linaro ARM Developer Cloud, the SoftBank Cloud, and the SoftBank IoT device platform. We've done it across multiple protocols implemented completely with open source code. We've also shown Lashan and Hawkbit device management platforms, and we've shown the micro platforms both for Cortex-M and Cortex-A, and we've delivered over-the-air updates using containers to the gateway. For more information on this, you can see any of the team, and you'll be able to see more of the technology behind this demo, as well as the tools and CI used to create it and test it at Demo Friday. Okay. So during this work, it's become very clear that there are substantial business opportunities for the Zephyr and Linux microplatforms within the open source ecosystem. But Linaro's core mission is to be the place where the ARM ecosystem collaborates on open source upstream technology, working directly in upstream projects. That's what Linaro is formed to do, to help the ecosystem work together in upstream projects. And this has been discussed by the Linaro board and at the Linaro member meeting, and we've concluded that there's a very clear difference between open source upstream projects, such as OPTEE, Zephyr, Open Embedded, and on the other hand, doing ongoing work on the use of these projects to create downstream products and services. And after discussions with everybody involved, we've taken the decision to transition this work and the Linaro Technologies team out of Linaro. And they're going to move to a new company called Open Source Foundries Limited that will be independent of Linaro and part of the open source ARM ecosystem. It's now seeking external funding. It will not be a Linaro-owned company. It will be competing and working just as others in the community. And we think this is important because we need to preserve Linaro's core mission for all of its members. So Alan and the team plan to continue working in the upstream projects of interest to Light and other groups within Linaro, including Zephyr, Open Embedded, and Kernel CI. And I'm sure they'll also maintain close links with many at Linaro as part of the open source community. And I hope that open source foundries themselves will join Linaro in the future and will come and demonstrate at Demo Day at the next Connect. I will be CEO of both Linaro and Open Source Foundries, and I'm very proud and excited that Linaro's created an opportunity to start a new business. I think this is a really positive sign for the work that we're all doing and shows the opportunities that open source brings to all of us. And I remain passionate about the future of Linaro and its core mission that we all have of helping the ARM ecosystem to work together on core enabling technologies. And I think what you've seen today is an example of those core technologies starting to come to fruition, and I really do believe that the work these guys are doing is going to make a big difference over the next few years in the embedded, connected world as we go through this disruption caused by connected devices. I'm especially proud of the engineering team that we have here in Linaro, now comprising over 300 of our own employees, our member assignees, and our member engineers, all of whom themselves are passionate about working in the community on upstream technologies. So lastly, what I'd like to do is talk a little bit about our plans for growing the Linaro ecosystem. We are introducing a Linaro Associate program that is going to be open to OEMs, ODMs, service providers, startups, and universities. And the goal here is to increase involvement from the wider ARM ecosystem to provide more end customer, end use case input and discussion in the Linaro steering committees so that we know that we're doing the right thing. We need to look forward. We're excited by the prospects for this program, and if you or your customers are interested in getting more involved in the work that Linaro is doing, then please contact us. So it only remains for me to wish you a very good Linaro Connect. I think it's going to be a great week, and thank you all for getting up so early to listen to me. Thank you.
Okay, really interesting stuff. We want everybody to have a great week.